Hey everybody, this is a video I made as a special request to RoccoFX. He asked to how you might make a blueprint that would land a ship from an arbitrary height onto the ground while sorting out the rotation. So in this case, you can see it's upside down, and then when I press F here, it lands it directly below upright, and this works for, I'll change the actor rotation here. You can tell that the components are rotated weird, but I'll rotate them in a second to show you. So actor rotation can be different, and if I go into the viewport, I can actually change the pitch and roll of the actor, or sorry, of the components in the actor here, and then play it, and it'll still drop you pretty much facing the same direction. There's a little bit of rotational weirdness. And down the line, I want to create some blueprint nodes that do some things rotationally that would be useful to have. Um, but I'll go ahead and show you how I did this one, just to give you some ideas to work with. And then you can build on from that. And then when I have more time on my hands, I want to build a particular blueprint node that I think would be really helpful in doing stuff like this. For rotations. So let's dive right in. This has two parts. The first part that we're going to need to do is to get it to land smoothly. Um, I'm going to go ahead and open this up and pull it into my other window. So if you see me looking, moving my mouse off the screen to look at this for a second, it's because I'm looking at what I did before. So let's create a new blueprint actor here. We'll call this landing actor 2. Let's go ahead and open it up. It's going to open it over there, isn't it? Yep. Okay, I'm going to go ahead and add a mesh. We'll just add a cube, since we know I'm going to use a cube. And I'm just going to call this the ship. Not a very fancy ship. I'm going to add a sphere. I'm going to call this the nose. And I'm going to shrink it down to 0.5. This is just so I can kind of keep track of which way is which on it when it rotates down and make sure that it's doing the right thing. I'm going to add another component and call it cube. Same reason. I'm going to rename that to top. And no, I want it to be at 0, and then I want to raise this up a little bit. So now we've got two markers to tell you this is the front and this is the top. And then we're also going to need to add, and I'm going to add this here for now, a spring arm. And to that we're going to add a camera. So now we've got a camera and a spring arm. And I'm going to raise the spring arm's angle up a bit here so that we're looking, behind it a bit. Alright, so now we've got a spring arm with a camera. And so there's a little bit of setup we want to do. I'm going to unhook it in the other blueprint, but then I'll hook it up in here so you can see what it is. Okay, so on event begin play, we need to enable input, which is important, and we need to do get player controller. My cat is meowing at the door. Apologies if you can hear that. There we go. And that's just so we can take an input. I was using the F key to start the landing sequence. And then the other thing we need to do is to set view target. Oh, sorry, it's off of this. Off the player controller, we set view target with blend. And I don't know why there's not just a straight up set view target, because we don't really care about the blend, so we're going to leave the blend time at 0. But what we need to do is get a reference to self, because what we're going to do is we're going to set the view target of this player controller to us, and what that'll do is it'll find the camera component on this blueprint and set it to this one. This can get really messed up if you do something like this and there's multiples out in the level, so I unhooked it in the original blueprint, and I'm only going to ever put one of these out there. This is my like fakey pawn code. It's taking a normal actor and putting the viewport into the camera of this and enabling input on it. There's a lot of problems with this. I would never see now my view's not going to the other one. So I'll delete that and I'll put landing actor in here. And now when I hit play, my camera snaps into there. Now I can't do anything with it yet because I haven't set anything up, but there it is. That's a landing actor 2 in the level now that we go into. So now let's go ahead and jump back in and start working on some of the actual code. So for this, I created 2 functions. The first is the landing control. So that's what's going to happen when you click it. And the other one is the landing loop. Now, you might be inclined to start the loop up here at event begin play, or to try and use a while loop inside the landing control. But because this runs every tick, I'm going to use that. There's problems with running a loop inside of another function. I frequently will wind up giving myself infinite loop detected errors in the game if I don't use event tick. I don't like that I am using event tick, and I think that oftentimes there's a better way to do it, but for our purposes we're going to do that. So the landing loop will be the thing that fires off every tick, and the landing control is going to be the thing that fires off when we press the F key. And we're also going to need a variable that is a Boolean that is landing. This is, are we landing currently? And we're going to need a vector that is landing position. This needs to be a vector. Yeah, there we go. And then we also, just to smooth things out, I have a slow land height that's a float. And this is just like, okay, we want to drop pretty quickly from high heights, but once we get close to the ground, we want to slow down. And I have that set at a default of 400. Landing is defaulted to false, and the landing position starts out at 0. So what we're going to do is when you press F, the first thing we are going to do is check to see if we are landing. And if we are landing, then we don't, well, yeah, I'm going to do a not here just to, because this is really what we want to know. If we're not landing, then we want to start landing. So if we're not landing, we're going to do a bunch of stuff. The first thing we're going to do is we're going to set landing to true. To say, okay, from here on out, we are in the landing mode. And then we're going to do a line trace by channel. So this is basically just to get the position directly under the ship. And the way that we're going to do that is we're just going to take the ship, because this is what we actually care about, is the actual ship model. And we're going to get world location. And that's where we're going to start. That's where we want the trace to start, is right at the center of the sky. And we want it to ignore self, because if it's starting at the center, it'll hit itself on the way out. And then where do we want to end? Well, we want to end where we break this, and we're going to make it into an make vector. So we want the x and y to be the same, but we want it to be straight below. So in this case, what I'm going to do is do minus, I don't know, 100,000 or something like that. It can be more if you are going to be higher up than that, but for our purposes, we'll do that. And we're going to break the hit result. So we have, sorry, my headphones are shutting down. There we go. Break the hit result, because we're going to need this location here. And we're going to set landing position. Okay, there we go. And okay, and then on this branch here, if we are landing. So if we're not landing, so we are actually landing, and you press F, we might want to stop the landing process. So we're going to set landing to false. So here we set landing to true. Hey, we're landing. We're going to do a line trace to find the position directly below you. And then we're going to use trace channel visibility. You can create your own channels, or you can use other channels. You could do line trace uh, by profile or by object, for specific objects if you only want to land on specific things like landing pads or something like that. But I'm going to use just visibility for now. So this is all we need in here for now. I'm going to come back to this in a minute when we start doing the rotation stuff. But I'm going to jump into the landing loop now. So remember, this gets called. This is going to set our landing position. Once we have our landing position, we're going to go into the landing loop. And once again, we're going to say, well, we only want to do the landing loop if we're landing. I don't want, this is going to fire off every tick. I don't want to be doing a whole bunch of stuff if we're not landing. So if we're landing, then what we're going to do is, let's see, what does this do? Oh yeah, so we're going to pull the shift out, get world location again, and we're going to subtract this from the landing position, and we're going to get the vector length. No, not path length. What is this? Oh, not get vector. It's just vector length. For some reason, it's not wrapped in a get, but whatever. So basically what we're doing is we're getting the distance from where you are to the landing position. And this is just to figure out, hey, am I still really high up? Am I in this like slow zone where I want to be slowing down at the bottom? Or am I there? So what we're going to do is we're going to get the absolute value of this. Just because I don't know if I subtracted in the right direction, I could have a negative. It should already be positive because vector length should be positive, but I'm going to put it through absolute value anyways. Somebody can complain in the comments about that. Please do. That's actually a useful thing to know, and I'm not going to figure it out right now. So here we go. Let me look at what I did here before. Okay, yeah. So if this is greater than or equal to our slow landing height, if it's greater than or equal to our slow landing height, we're going to do one thing. If it's not, then if this number is less than our slow landing height, but also, less than our slow landing height, but this is also greater than, and this is an interesting number here. The origin of our ship, notice, is in the middle. So we want to use half this. I happen to know that this cube is 100 on each side, 100 length, height, and width. But you're going to want to figure out whatever the distance from the ground to the origin of your ship model is, and put that in here. So what we're saying is, hey, if the ship's position, the origin, is below the slow landing height, but it's still above this point where the feet will be touching, what we want to do is and something else. So this is our next case. And if that's false, we're going to set landing to false. So this happens every time landing is true, and it's going to keep firing through all these until this, and then it's going to turn this off, and all of this will stop firing. And that case should be, hey, we're not above the slow landing height, and we're not in this mid-range. That means we have to be at or below. And you can add the below just in case. Pardon me, excuse me. Seasonal allergies are really killing me here. Yeah, so you can do some like more. handling for what happens if you get below and stuff, but this will work for our purposes for now. All right, so if this is true, what we want to do is we want to set linear velocity of the ship, and we're just going to set it to maybe 1,000, I think is what I did before. And we're not going to add it to current. We're just going to set this as 1,000 because what we want to do is, even if you're moving, we want to just be like stop. If you want to ease into this, you're going to have to build some code around this where you like have a you add it to current, and then you're going to want to put a cap on it. You're going to want to say like if it's greater than somewhere in here, you'll add to current, but then if it's greater than whatever your max speed is in the z direction, then you're gonna clamp it. So you'll have to work on code for that. But this is just to do the lowering, which I take it is the less important of the two parts. And then we'll say we're gonna do the same thing, but here for this slow landing region, we're gonna descend at a rate of like, I don't know, like a fifth of that, minus 200. And then if landing is false, what we're gonna do is the same thing, except for it's going to go to 0. So that's actually this case here. As soon as this happens, then this will take effect the next tick. So what we're going to do is we're actually going to go to 1 greater. So as soon as that origin drops below that point, it's going to set this linear velocity to 0. And that actually might, so you might need to mess around. Because this is linear velocity, also you need to simulate physics on your ship. If you're not doing steering with simulating physics, then this is going to all come apart. You're going to have to, instead of doing linear velocity, you're going to have to do it move an amount. You're going to have to actually translate the position per tick, which will look really smooth because the ticks happen however many times a second, hopefully more than 60 times a second. But yeah, I'm doing linear velocity and I'm using physics on the ship. This should along with collision, keep it from penetrating the thing. If you're using changing position instead of linear velocity, then you might get some penetration and depenetration, so you're going to want to be more careful about these speeds and slowing it down so that you can translate it directly to that point. Once you get below a certain distance, you're going to want to just snap it to whatever this landing position is, plus the distance between the ground and the origin of your ship, like this number, whatever it is. So what this should do, if I have everything hooked up correctly, is when we hit play, no, sorry, I have gravity on, so that's going to F everything up. Ship, enable gravity is off, turn off. There we go, okay. So now we're not moving, and then we press F, and it goes down. Now, that's because it looks weird because the camera is not on the, so the other thing you can do, if you don't want the camera to be fixed to the ship, right? Like if you want the camera to stay upright and the ship to do maneuvers in front of the camera, but the camera's always like in the upright plane, quote unquote, then what you can do is you can because this is using linear velocity, you have the ability to do this. If you're setting relative location, this is not going to work. But you can set actor location to the ship's world location. Get world location. And if you do that every tick, come on, there you go, then you should not have this camera following problem. There you go. It looked kind of jerky, whereas on the original it didn't. I'm wondering why that is. You could probably sweep. That might smooth it out. Did not. Huh, that's interesting. But the other way you can fix that is, if you don't want to do that, is affixing the spring arm to the ship itself. File, And that's going to give you a nice smooth motion because they're actually attached. So now the question is, what do we do if you've been doing some maneuvers, um, and so you're upside down when you start, and then you do this, how do you get it rotated upright? So that's the next part of this. So let's go ahead and jump right into that. This, I'm using a timeline, so let's go ahead and get that out. I'm doing it at 3 seconds because I assume usually it's going to take longer than 3 seconds to land, but you're going to have to solve for the case where you're less than 3 seconds off the ground. Figure out like, oh, what the height is. If the vector length is greater than this, use a different timeline, like a quick land timeline, or maybe you go slower or something like that. You figure out how to make it work for those distances where it'll be more than 3 seconds. But this is rotation timeline. And whenever I create a timeline, the very first thing I always do is come up to event begin play, and grab the rotation timeline, get and set active. Because for whatever reason, if you try and play it from in a function right now, it won't play unless you set it to active. And now you can set it to active right when you try and play it, but then it'll just keep doing that whenever. So I always do it right at the event begin play, set active. So now we've got our timeline, and we want a float track. We're going to say 3 seconds. Come on. 3 seconds. And right here, I'm going to add a keyframe. I'm going to zoom out to 3 and add a keyframe. Let's get these exact 1 and 3 seconds. And this is going to be 0, 0, and 0. Okay, there we go. So there we go. Got our 2 keyframes. Save this. I'm going to exit. So that's going to drive our rotational behavior. Event graph. And you can wrap everything that I'm going to do here for driving the rotation in a function and just call it on update, but I'm just going to build it out here. So all I'm doing is set relative rotation of the ship. There it is. We're going to set the relative rotation of the ship, and here I'm going to use an ease, and I think I'm using it on exponential in out. That's going to give us a little bit nicer motion. And our alpha is going to drive this easing function here, and I want it to use the shortest path. And the result is going to come into here, which means, hey, we need 2 rotators. So let's get the rotators. And what I'm going to start with is the relative rotation of the ship. No, that's not what I want. I want get relative rotation. And that's going to be our starting point. And what I want the relative rotation to be is the same as rotation. Get the actor's rotation. Now, this only works if the actor itself is handling the yaw rotation, right? So, for instance, if you're rotating this guy, if you're using the yaw on this, and the actor is staying at the same rotation entirely, then what's going to happen is you're going to be facing this way, and it's going to snap you around to the actor's 0. So this only works if you're pitching and rolling inside here, but you're using the actor itself. So you can add some of that and do this. But then for the rotation itself, we're using the actor's yaw. So when you're building your flight model, you'll want to make sure that you're using the actor's yaw. Now I realize that getting the rotations of a flight model sorted out are super complicated. So it's not working because we haven't called this timeline. So now what we need to do is call the timeline from inside our landing control. So we're going to go to components. We're going to grab a rotation timeline. We're going to get this. Play from start. My guess is that given your flight model, whatever that is, there's a dozen ways to do it. This isn't going to work exactly, so you're going to have to fiddle around with exactly what needs to happen in the event graph. Do you start with just the straight up relative rotation, or do you want to do just the roll and pitch of the relative rotation? You know, and where do you want to go to? Do you want to go to the actor's rotation, or maybe you're not rotating the actor, so you need to get a rotation based on a world vector, you know, or the forward vector of this guy or something like that. But what we're going to do is just use this like that, and then in landing control, if let's say we start landing, but then we want to stop, we're going to want to stop this timeline, because otherwise you'll lose control, because this is forcing a rotation that you're not inputting. So copy this guy over. I'm going to stop it. Not strop it. Oh my gosh. STO. I can't type this morning. We're going to stop the timeline. So now, and rotates, drops you, and you are landed. So that's the whole thing. So let's talk about the individual parts. The line trace by channel, I'm going to turn the debug on persistent here. This works really well for finding an object below you. Now, you can have it, I believe, ignore certain actors, and this could be really useful if you have certain things that you want it to pass through that are visible, like, you know, like holographic landing zone markers, or I don't know, foliage that you want it to just, you know, go through. You don't want it to hit the treetops. You just want it to land on the ground below the canopy or something like that. So you can have it ignore these actors. But what it's going to do is it's going to line trace straight down. And I'm going to disconnect this setup thing that we did to put the camera in it, because I don't want the camera to go there. I just want the camera to stay where it is. Okay, yeah, so now when I press F, you can see there, it line traces, finds that point, and then it lands it on that point. And that will work for any height whatsoever. I mean, let's fly this guy like way the heck up. Assuming I don't get above 100,000, we should be fine. Play, there it is, that's straight down. And now it's landing, and it's going to keep doing this landing pattern. It's kind of slow for how high up we put it, but it's just going to keep up at this landing speed until it gets to the slow landing height, and then it's going to slow itself down, and once it does that, there it is, it'll land. So let's go ahead and take us back down a little bit. Too low. And you can see that it's also going to keep its general orientation. So it's still generally facing the same direction, and that'll hold true if you're over here. That way the player won't feel disoriented. So now it's facing this way. When they land, it's going to be facing generally the same direction. My hope is that this will give you enough to work with for the time being. The problem with rotations, I'm going to say this really quickly. The problem with rotations is that Unreal gives us two really great tools. Set world rotation and set relative rotation. But the problem is that it doesn't give us a third tool that I think, in cases like this, really need. And that is set self-relative rotation. So this uses the relative rotation of whatever this guy's parent is. So in this case, it's the actor. But that can cause some really weird behavior where if, you know, for instance, say I have this like this, and I want to, and I use set relative rotation or add relative rotation, and it's a and I roll it. Well, this is the actor rotation, so what it's going to do is roll it like this, even though obviously what I want to be doing is rolling the ship, which based on the ship is going to be this rotation. This is roll for me right now, but what it's using is this. It's using actor relative rotation. It's using the relative rotation of the parent. And I want to use the self-relative rotation right here. And as far as I can tell, there isn't any tool in Unreal that does that. So my hope is to add a node that we can use instead of this, that it would be self-relative rotation that's going to use the same, it's basically using this widget instead of this widget. Because I don't care about, this roll is weird. Like, this is a weird rotation. I don't know why I would ever want to use this for a ship. What I really want is this. So I'm going to try and figure out the mathematics for that. There's a little bit of trigonometry involved, I think, to translate based on a forward vector to get the rotation. And I'm hoping to build a blueprint node, and if I can successfully build a blueprint node, or if not a blueprint node, a blueprint that can be called from inside another blueprint that you can just add, then I will release the video on how to build that and also release the node so that you guys can use it. That'll make everything a lot easier because then you can leave the actor alone and you can get the forward vector. So what I want is to say like, oh yeah, just make it so that roll this guy so that he's upright. You know, I want my roll to be 0 and my pitch to be 0. Right? Like, why is this so hard? Can I just pitch 0, roll 0, and there you go. That's what I want, is to be able to get up in this upright position, but still keeping this forward vector, right? Like, just because I do this, and like, yeah, if you go to that, it's a really weird angle, but it's not that weird to it. You just need to set that to 0 and that to 0, and now we're facing the same direction, even though we've left our yaw in the, yeah, anyways. End rant. Hope this was helpful, at least for what you're doing right now, and then I will try and make that video sometime in the next while. I don't know how long it'll take me. It's something that I've wanted for a long time, and it seems like, from the way that you asked the question, it's something that would be useful to you as well. So if anybody else wants that, leave a comment, and otherwise, peace out, and I hope this helped.